So equations of lines, we're going to look at two main forms. One, the slope-intercept form, which is y equals mx plus b, or f of x equals mx plus b. And then the other form we're going to look at is the point-slope form of a line, which is y minus y1 equals mx minus x1. And what we need to know for the second form is a point that the line goes through and the slope of the line, which is m. Whereas, so this is what we need for the second form. What do we need for the first form to get that equation? It's basically the slope and the y-intercept. So for both equations, we need two things in order to come up with the equation of the line. For example, if I have to find the equation of the line through the point 0, 5 with a slope of 1/2, I could recognize that the point 0, 5 is already the y-intercept because the x-coordinate associated with it is 0, and I'm given the slope, so it would be best if I use the slope-intercept form of a line, which is y equals mx plus b, and I get there fairly quickly. I plug in the slope of 1/2 and the y-intercept of 5, and I'm good to go. Or for example, if we're told find the equation of the line in point-slope form this time, through this given ordered pair -1, 2, which would be our x1, y1, and slope of -1/2. So if it's at point-slope form, I'm going to write down y minus y1 equals m, x minus x1, and then use the pieces accordingly. Y minus, well, y1 from up here is 2 equals m is -1/2 times x minus x1, which in this case is a -1, and double negatives make a positive. So this is the equation in point-slope form, and it's good to note that the equation in point-slope form is not unique. It depends on what point the line goes through. And I don't have to simplify any further because it said give it to me in point-slope form. Now let's say it was the exact same problem, but it said give the equation in slope-intercept form. Well, all I have to do is take the point-slope form, which is y minus 2 equals -1/2 x plus 1, and simplify it. Once I simplify it, I'm going to have it in point-slope form, or in slope-intercept form. So I have y minus 2 equals, we have -1/2 x minus 1/2. Now I'm going to isolate y to get it in y equals mx plus b form, and that's going to give me y equals -1/2 x. Remember, I have to add 2, a positive 2, and take away from it -1/2, so I'm going to need a common denominator. Common denominator is 2, so I multiply top and bottom by 2. That's going to give me 4/2 minus 1/2, which is 3/2. So it looks like our y-intercept in this case is going to be a positive 3/2, and there's my equation in slope-intercept form. So to get from slope-intercept, or from point-slope form to slope-intercept form, all I have to do is pretty much simplify it and isolate y. So slope-intercept form, again, is not unique. It depends on the point given. If I change that point, this equation right here is gonna change as well. And the slope-intercept form is unique because there's only one slope a line is gonna have and one y-intercept. So anytime, it doesn't matter what ordered pair they give me, once I put it in point-slope form and I transform it into slope-intercept form, it's always going to be the exact same equation, regardless of what point was given. Parallel lines have the exact same slope. In other words, if I have the line y equals 3x plus 4, and I have the line y equals 3x minus 10, let's say, both in slope-intercept form, since their slopes are the same, I'm going to have these two lines be parallel. So the minute the slopes are the same, the lines are going to be parallel. Whereas if I have two lines that have opposite reciprocal slopes, for example, y equals 3x plus 4 is one of them, and y equals, make the 3 opposite, so that's negative 3, and then also take its reciprocal, so that's negative 1/3 x, I don't know, let's say minus 10. If we look at the two slopes, this is a positive 3, this is a negative 1/3, and they have opposite reciprocal slopes, which means perpendicular line is what we're looking at. And that means, of course, they intersect at 90 degrees, at a 90-degree angle. They look, if I were to graph them, one of them would look like that, and the other one would maybe look like that, and they intersect at a 90-degree angle. Whereas for this one, they would both have the same rise over run, the exact same slope. One last thing, anytime we have y equals a constant, a number, it's going to be a horizontal line. For example, if I have y equals 2, that's just going to be a horizontal line going through the y value 2. Or if I have y equals, I don't know, let's say negative 3, that's just going to be a horizontal line going through negative 3. If I have x equals b, or x equals some constant, that's always going to be a vertical line. For example, if I have x equals 2, 1, 2 is going to be the x value, and it's going to go through x equals 2. Or if I have x equals negative 3, it's going to be the x value of negative 3, and my line is going to go through x equals negative 3. A horizontal line has slope 0, whereas a vertical line has undefined slope. So if you can look at our horizontal line, y, this one remains at 2, and the x's vary and go to the left and the right. Whereas if I look at the second example down here, x equals 2 says the x value is always 2, but the y values vary, and they go up and down in both directions.